Welcome everybody once again. So we have completed our 3 modules and we are going to start our 4th module. So 4th module deals with flow in open channels and flow through open channels. That is, in flow in open channels you will be studying what are the concept, why it is called open channel flow, why the flow is said to be open channel flow, and what are the different classifications of a flow in open channels. And under the topic flow through open channels, you will be studying the channels, different channels called notches and weirs. Already in the 3rd module, we have studied flow through pipes. Okay, flow through pipes means the flow, when the liquid is flowing through pipes, it flows under pressure. And when the liquid is flowing in a channel, there will be free surface of water which is open to the atmosphere. That is the difference between open channel flow and flow through pipes. And when the pipe is not flowing full, see, if the flow of water is, this is the free surface of water, and if the pipe is not flowing full, that also comes under, that also can be dealt with open channel flow. Now, what is flow in open channels? How it is defined? So flow in open channels is defined as the flow of a liquid with a free surface. Okay, so there should be free surface. See, when you are taking a pipe, when it is flowing full, there is no free surface. Free surface, it needs, that is, it coincides with the surface of the tube. Then that is not free surface. Okay. Now, it is defined as the flow of a liquid with a free surface. So, it should be flowing half. It should not touch the top surface. So, in channels, in open channels, you can see around you. You can see in your surroundings, you will see the channels which are flowing openly. The free surface of water will be open to the atmosphere. So, that is called flow in open channels. Now, a free surface is a surface having constant pressure such as atmospheric pressure. So, in the free surface, when it is open to the atmosphere, it will have a constant pressure, and that pressure we call it as atmospheric pressure. A liquid flowing at atmospheric pressure through a passage is known as flow in open channels. So, it can be any passage. It can be open passage or closed passage. But if the liquid is flowing at atmospheric pressure, you will call it as flow in open channels. Now, the flow of water through pipes at atmospheric pressure, or when the level of water in the pipe is below the top of the pipe, is also classified as open channel flow. That is what I told you earlier. Right? When you are considering a pipe, if the level of water is below the top of the pipe, then this flow is also classified as open channel flow. Now, how can you classify the flow in open channels? So, classification of a flow in open channels, it can be classified into steady flow and unsteady flow, uniform flow and non-uniform flow, laminar flow and turbulent flow, subcritical, critical and supercritical flow. Already we have studied the classification of a flow in our previous modules. So we know if it is a steady or unsteady flow, this is with respect to time. Steady and unsteady flow is with respect to time. Uniform and non-uniform flow with respect to space. Laminar flow and a turbulent flow is the type of a flow based on the Reynolds number. Now, subcritical, critical and supercritical flow are based on Froude's number. You have not studied this Froude's number. The first time you are studying Froude's number. Okay, so we will see what is Reynolds number. Already you have studied. So these are the classifications of a flow in open channels. So we will see one by one. So first one is steady flow and unsteady flow. So for steady flow, I told you the flow with respect to time. So if the characteristics of a flow with respect to time is equal to 0 is constant. See, when you take the differentiation, if something is constant, then the differentiation is equal to 0. So velocity with respect to time is constant. Flow with respect to time is constant. The depth of flow with respect to time is constant. So the characteristics, there may be some other characteristics also. Okay. So at any point in open channel flow, the flow characteristics such as velocity of flow, rate of flow, depth of flow, etc., they do not change with respect to time. Then you call it as steady flow. Similarly, for unsteady flow, these characteristics changes with respect to time. So if the characteristics are changing with respect to time, the differentiation of these characteristics with respect to time is not equal to 0. Okay, so for unsteady flow, at any point in open channel flow, the flow characteristics such as velocity of flow, rate of flow and depth of flow, etc., it changes with respect to time. Then you call it as unsteady flow. Now, the second classification is with respect to space. You call it as uniform flow and non-uniform flow. So for uniform flow, the flow characteristics are constant with respect to space, and for non-uniform flow, the flow characteristics are not constant with respect to space. So it is with respect to space. So that is why you are differentiating with respect to space. So S means space, okay? So dou V by dou S is equal to 0, dou Y by dou S equal to 0 for uniform flow. So for a given length of the channel, see there, for the first case, it is at any point, you are considering any point in open channel flow. For steady flow or unsteady flow, we will consider some point in the open channel flow. Here, for uniform flow, you are considering a given length of the channel. Okay, so when you are considering uniform and non-uniform flow, it is with respect to space, and you will consider a length of a channel. It is taken for a particular length of the channel between two sections. Okay, when you are taking channels, you can consider two sections. So within this length, what is the flow? So for a given length of the channel, the velocity of a flow, depth of a flow, slope of the channel across the section and cross sections, slope of the channel and cross section of the channel. So these characteristics remains constant. And for non-uniform flow, for a given length of the channel, the velocity of flow, the depth of flow, the slope of the channel. See, slope can be represented by I. So it can be dou I by dou S equal to 0 for uniform flow, not equal to 0 for non-uniform flow. And cross section of the channel, cross section area can be represented by A. So you can take it as dou A by dou S. So they do not remain constant. You call it as non-uniform flow. Now, this non-uniform flow can be classified into rapidly varied flow and gradually varied flow. RVF means rapidly varied flow. GVF means gradually varied flow. So rapidly varied flow means, fast. The variation is greater. Gradually varied flow means the variation is smaller. It is gradually varying. So in general, see, rapidly varying flow, it is greater. So the distance, the length or the distance will be smaller length. Gradually varied flow, the distance will be larger length. See, you may have the variation, same variation, right? So this distance can be taken as y. This variation of this distance can be taken as y. Okay, so this distance is y. So here you see the variation is y. The depth is the same, but the length is smaller in the case of rapidly varied flow. The length is larger in the case of gradually varied flow. So you see, automatically this will be rapidly varying flow. This will be gradually varying flow. So this non-uniform flow is classified into rapidly varied flow and gradually varied flow. So we will study this in detail. So with the help of this diagram, So you can see this is an open channel. Okay, this is the open channel and this is the flow. This is how the water is flowing and this is the free water surface. So this is the free water surface. So water is flowing like this. Water or any liquid is flowing like this. There is an obstruction. Okay, so this is some obstruction placed or it is in the path of the flow of the liquid in the open channel. Right? Now, you can see from this to this, from here, from this point to this point. So from this to this point, you can see there is no change. It is uniform flow. The depth is the same, the velocity will be same, the discharge will be same. So this part up to this, you will call it as uniform flow. So after uniform flow, because of this obstruction, it is changing. The flow characteristics are changing, right? From here you can see the change. So this is called non-uniform flow. So see from this part to this part, this is uniform flow. From here to the remaining this much, it is non-uniform flow. Again, if there is no obstruction, this non-uniform flow can be changed to uniform flow. Gradually, it will be converted to uniform flow when it moves on. Now, we know non-uniform flow can be either gradually varied flow or rapidly varied flow. So you can see from this point to this point, you can see here this portion, it is gradually varying. So this portion you have gradually varied flow. Then when it comes to the obstruction, see this flow comes down and then rise. So sudden fall and sudden rise. So for this portion, so sudden fall and sudden rise. So for this portion, from this to this portion, see from this to this portion, there is a sudden fall and sudden rise. So this type of flow, between this portion, in this smaller portion, there is a rapidly varied flow. So hope you understood gradually varied flow and rapidly varied flow. It comes under non-uniform flow. So what is rapidly varied flow? It is defined as that flow in which depth of flow changes abruptly over a small length of the channel. Now, when there is any obstruction in the path of the flow of water, the level of water rises above the obstruction and then falls and again rises over a small length of the channel. Thus, the depth of flow changes rapidly over a short length of the channel, and for this short length of the channel, the flow is called rapidly varied flow. So, gradually varied flow, if the depth of flow in a channel changes gradually over a long length of a channel. Okay, so long length, it is gradually varied flow. Short length, it is rapidly varied flow. So if the depth of flow in a channel changes gradually over a long length of the channel, the flow is said to be gradually varied flow. Now we will move on to the third type of flow, that is called laminar flow and turbulent flow. We have studied it already. This depends on the Reynolds number. Right? Re means Reynolds number. And this Reynolds number is represented by rho VR by mu. It is nothing but VR by mu. Mu is dynamic viscosity and nu is kinematic viscosity, where nu is equal to mu by rho. So these things we have studied in our first module. So Reynolds number is defined as rho VR by mu, where rho is the density of the given liquid, V is the mean radius of the flow of water. Sorry, it's not mean radius, it is mean velocity. V is the mean velocity of a flow of water. R is the hydraulic radius or hydraulic mean depth. In the case of open channel flow, this R is hydraulic radius or hydraulic mean depth. We have already studied hydraulic radius and hydraulic mean depth while we are studying the chassis formula to determine the losses, major losses. In our third module, while studying the major losses, we saw chassis formula for the calculation of major loss. So while using chassis formula, we saw what is mean depth, what is hydraulic mean radius, right? Or hydraulic mean depth. So that is equal to cross section area of a flow normal. So cross section area by wetted perimeter. Area by wetted perimeter. That is what we saw in the previous chapters. Area by wetted perimeter. Here in the case of open channel flow, it is cross section area of flow normal to the direction of flow. So when you are taking a channel, when there is a flow in this direction, you are taking the cross section area of a flow normal to the direction of flow. So what is this cross section area? Right? Cross section area of a flow normal perpendicular to the direction of a flow divided by wetted perimeter. And rho is the density of water, mu is the viscosity of water or dynamic viscosity of water. So see, laminar flow, in the previous cases we saw if the Reynolds number is less than 2000, you will call it as laminar flow. Here, for the open channel flow, if the Reynolds number is less than 500 or maximum 600, you call it as laminar. The flow in open channel is said to be laminar. So, for open channel flow, the Reynolds number is less than 500 or 600. Now, if it is greater than 2000, the flow in open channel is said to be turbulent. So there is a difference between flow through pipes and flow through open channels. For open channels, if the Reynolds number is greater than 2000, you will call the flow as turbulent. And if the Reynolds number lies between 500 and 2000, the flow in open channel is considered to be in transition state. Now we will move on to the next classification of a flow, that is a subcritical flow, critical flow and supercritical flow. So critical, subcritical and supercritical is based on Froude's number. Froude number, we represent it by Fe, Froude number, and that is equal to V by root of GD. So remember this, Fe, Froude number is equal to V by root of GD. So what is V? V is the mean velocity of flow. D is hydraulic depth of the channel. D is the hydraulic depth of the channel, and that is equal to wetted area by top width of the channel. Wetted area divided by top width of the channel. So it is represented by A by T, wetted area by top width. And see, this classification is based on Froude's number. You can calculate the Froude's number, and if the Froude number is less than 1, the flow is called subcritical flow or tranquil flow or streaming flow. And if the Froude number is equal to 1, the flow is said to be critical flow. If a Froude number is greater than 1, the flow is called supercritical flow or shooting flow or rapid flow or torrential flow. So that is all for today. So since we had only some theory part, we have completed it today's class earlier. The next class we will see what is the discharge through open channel by chassis formula, and how to determine the chassis constant using Basin's formula, Cutter formula and Manning's formula. So you have Cutter's formula and Manning's formula in your syllabus. You are not using Basin's formula. So these things, and if possible, the problems related to the discharge through open channel by chassis formula, we will study it in the next class. Thank you.